9119725 Is it pound sign? Welcome. Okay, I remembered it. Yes, great. You basically wrote a keypad scanning algorithm yourself, which is actually really amazing. Hi everyone, my name is Bhavesh Kakwani. You can call me Bhav. I love sharing and teaching stuff, and recently I've been getting super into MicroPython. MicroPython is really cool because it lets you develop on hardware, but like really fast without having to worry about all the nitty-gritties of working with something like Arduino or C++, where you have to constantly be compiling, flashing your code, using a debugger or etc. Whereas in MicroPython, you just get to try lots of things really quickly. And that got me super excited. So excited, in fact, that I started writing lots of tutorials on the internet and with this wonderful art here by Natalie Puchenik. If you want to check it out, go to my website, bhave.sh, which is my first name. And what you'll find is some really in-depth tutorials where I kind of show you some examples of what you can do with these projects, but also explain really in depth both the hardware side, the software side, and even like, for example, in this case, color theory. So the theory of the actual project itself. I provide animations to help you understand exactly what kind of outcomes you expect. And I provide even some flowcharts so that you're not constantly having to think in Python to understand the core of the problem, but you can break it down at a higher level and understand how to solve programming problems in the embedded space in general and not just Python problems. So I highly recommend you check it out. For today, however, I decided why not do my tutorial as a video? And I find that video is a really cool format, and maybe it will help you to see me go through the process, explain my thought process as I write out each line of code and iterate through the hardware concepts. So I hope you're super excited because today we're going to be learning about how to use keypads. And keypads are basically, you may have seen these, they are something like this, where you use it to enter maybe a password to enter a door, or maybe you have a keypad on your old school Nokia phone from 20 years ago where you type in the phone number. And the way they work is pretty interesting. They have all these different pins, and we're going to get into that today. So let's get right into it. Um, we are going to use this amazing online simulator called Wokwi, WOKWI. And what this allows us to do is we don't even have to use real hardware. You don't have to go out and buy a keypad or a Raspberry Pi Pico or whatever. You can learn MicroPython right in your browser totally for free. And this is how I've been learning, and I think it's super awesome. And so what I want you to do right now is to go into Wokwi, wokwi.com, and scroll down. You will see down here MicroPython on Pi Pico. That's your project template. So you click on that. And as soon as you get in here, you're presented with this really sweet interface. If you've been following my tutorials, you already know this, but I'll just go over it really quick. So on this side, you have your code editor. So this is your Python code, and it's just a simple kind of hello world style project right now. And then on this right half over here, you have your simulation pane. So this is where you have the Pico, but also interestingly enough, you can add more hardware and connect it up, wire it up, and then play with it on the code side over here. So it's really cool. No hardware needed. You just get to do it all in your browser. So just to get started, let's pull in one of these matrix keypads and see what it's like. So click on the plus button and click on keypad, and you get this humongous thing, and it has blue buttons, red buttons. Okay, what is going on? What's down here? We got some pins, R1, R2, R3, R4, C1, 2, 3, 4. Very interesting. So 16 buttons and 8 pins. And I wonder how it works. I really wonder how it works. I'm just going to zoom out a bit here so you can get it all into view. Yeah, so we have eight pins here. So I've pulled up a schematic that kind of explains what's going on underneath the hood here. And this is the schematic. So each of these switches here represent one button. So for example, this is the button for number one, this is for A, this is for the pound symbol, and so on. And each of those switches has a potential connection to 4 rows of pins. And then on the other side of that, to 4 columns of pins down here. You can use some clever digital logic to figure out if any of these buttons are being pressed. And the way to do that is you apply a high voltage on the row pin here, and you should see a high voltage right here at this node. However, if someone is pressing down this button, what actually happens is this circuit gets closed. And so you actually see a high voltage all the way down here at the column pin. And so the idea is basically if I apply high voltage to a row pin and then I check all 4 column pins, if any of those 4 are also high voltage, it means that that button is being pressed because it allowed the circuit to be continuous down to that point. And so what our code is going to do is basically just constantly go through every single row, apply high voltage, and then check every single column to see if it is received in a way on the column side. And then you know that that key is being pressed. A couple things to keep in mind, just to differentiate between when we are pressing the button, we do want to put a pull down resistor on the column side so that it's by default it's low voltage, and it only becomes high voltage when we apply the high voltage. So we're going to put a pull down resistor over here, and I'll show you how to do that in MicroPython code. It's actually extremely simple. So let's get right into it. On the hardware side, we want to connect the pins first before we write any code. So here we have our 4 rows, which are R1, R2, R3, R4, same as these. And then C1, C2, C3, C4 will represent the columns. So we can just connect them to any digital pin, and I am going to connect them to 15, 14. Make sure to not connect any ground pins when you do this. So that's a ground pin, for example. So avoid that. There you go, 13 and 12. Then so on, 11. That's ground, 9. Yeah, and that's really it. You didn't need any real wires to do it. It's pretty awesome, I think. We're gonna get into this side, and as usual with every MicroPython project, we want to import our main 2 libraries, which are time and machine. And those let us do almost everything. So from time, import sleep, and then we're going to go from machine, import pin. So we can start playing with the digital pins. And the way we're going to do these is going to make lists for each of the pins. So we're going to have a list of row pins, and we're going to have a list of column pins. And we're going to just populate them. So as we know, the row pins are pins 15, 14, 13, and 12. I'm going to just use a for loop because I'm a bit lazy. I want to set it up programmatically. So we're going to go use a range function. Pin number in range 15, 11, -1. The reason it's 11 instead of 12 is because you may know in Python, when you use the range function, the stop point in the range is actually 1 after the point that you want. So this will actually spit out 15, 14, 13, 12. 11 is not going to be included in that range. So for these pin numbers, I'm going to append them into our list. So we're going to go row pins, append. We're going to create a pin using the machine library. And we are going to make these pins output because, as I said earlier, we want to apply high and low voltage to those row pins to scan the whole matrix. Likewise, on the column side, we're going to do something similar, but instead of making it output, we are actually going to make it input with a pull down resistor. Column pins dot append pin number and pin dot in, and then a third argument, which is pin dot pull down. And that's it. You get a pull down resistor on all those 4 pins. So starting from 11, 10, 9, and 8. Great. Next up, we actually want to have some way to represent a key. And the way we want to represent it is we want each key to both have a character associated with it or a name, such as 2, 3, a pound sign, just the symbol for it. And we also want to track for each key whether it is currently being pressed or not. As in, does our code think that this key is being pressed right now or not? So I call that whether the key is active or not. So we want each key to have a name and whether it's active or not. And a very simple way to do this in Python is to create a class and use it just to kind of store our data, our custom data structure. So I'm going to create a class called key, and it's quite simple. It has an init function or a constructor, as all classes do. It's going to take a name as an input, so you can instantiate an object of key with 1 or 7 or pound sign. And let's do self.name equals name. So that's its attribute. And self.active equals false. By default, the key is not pressed. And the purpose of doing that actually was to use that to create our own matrix, which is basically a two-dimensional list of all the keys. And we're going to use that soon to be able to scan through them and to see whether they're being pressed or not. So I'm just going to create this 2D list. So it's a list of lists, which represents the rows and columns. So for example, this first row will have key with a name of 1 and key with a name of 2, and so on and so forth. Just to save some time, I've written it out over here, so I'm just going to copy it over. We have the whole keypad that we can copy in. And yeah, so this is row number 1. It's a list with 4 keys in it. Row number 2, row number 3, and row number 4. And within each of those, you can treat those as columns in a way. And so now that we have this, we have this 2D list of keys. We have lists of rows and column pins. Now we can apply our scanning algorithm. So like I said before, we want to go through each row, switch it on, check if any of the columns read high voltage, and then switch that row off, and then go to the next row, and just keep doing that over and over again. So I'm going to create a function called scan keys. And before we jump into writing code, let's just kind of describe in comments what we're trying to do. So I'm going to say turn on each row and check each column to see if the key is pressed. Turn off the row. That's just 3 steps. And it's going to be a for loop within a for loop. So we're going to go for loop through the rows and then for loop through the columns for each row. So let's just do it. For row pin enumerate row pins. Okay, if you haven't used Python enumerate, by the way, before, what it does is it basically takes a list, so in this case, the row pins list, and not only does it give you the item in the list, which in this case would be the pin, one of these pins, but it also gives you like an index. So 0, 1, 2, 3, 4, like it gives you a counter. And that's really useful. It's a really nifty thing. So instead of me having to track my own counter, I just use Python enumerate, and it's a lot easier to track which array counter we're at. So we're going to turn it on, row pin dot on, and then we're going to for loop through the columns. So for column pin in enumerate, so same trick there again, column pins. I'm going to go through all the pins in the column pins. Check each column to see if the key is pressed, and I should add here, and set that key to active in the keys matrix. When I say keys matrix, I mean this is a keys matrix here, this 2D array. We want to take that object and set its active to true whenever we see a high voltage over there. So we're going to say keys, row, column. So now you see those array indexes are coming in handy from the enumeration. Keys, row, column, that's where we are. Dot active equals Boolean of the column pin's value. And basically the Boolean means like, so if the column pin sees high voltage or 1, the Boolean of that is true. And if the column pin sees low voltage or 0, the Boolean of that is false. So we get a true or false out of it. And then finally, we want to turn off that row. So very simple, row pin dot off. Beautiful. And that's our scanning algorithm. So it goes to each row, turns it on, checks every column to see if we see a high voltage anywhere, and then it turns off that row. And you might notice it's not actually outputting anything from this function, and that's because it's directly writing to this keys matrix, so we can look in there to see what the output is. Basically, we can see each key and see if its dot active attribute is true or false, and that's how we know if it's on or off. Cool. We are at this point just about ready to test out our code in a main loop. So let's just write a main loop. And as usual, it's just while true, so it runs forever. And what we're just going to do is very simple. Let's just see if this even works. So we scan keys, and then we're going to iterate through it and see which ones are true. So for row in keys, for key in row. Okay, so it might sound a bit confusing, but what I mean by this is for each row in this keys array, go through each key in that row. So you're just iterating through a double list, right? If key.active, so if our scan keys algorithm thought this key is pressed, we're going to print something. So we're going to print key.name. And otherwise, we don't print anything. So ideally, this just prints out every button we press, right? Let's try it out. Let's see what happens. So I'm running the sim. Just had to click play up there. And let's click on 2. Whoa! What's going on here? B. It always says 0. That's strange. I found it. Okay. I forgot to put this for loop inside as well as this code. This was not inside this for loop. Okay, so now this is why they give you this vertical line right here so you can see whether your for loops are inside each other. Okay, perfect. So I think that should fix it. Let's try it again. All right. 2. Whoa, what's going on? I just pressed 2 once, which says 2, 2, 2, 2, 2, 2, 2. 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. C, 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 C. Okay. So that's pretty strange. It's working, but it doesn't really just show it once. It shows it a whole bunch of times, and that's not great. I don't want to not know how many times someone pressed something. Like, what does it actually want to press C 4 times in a row? There's no way for me to tell. So what we need to do here is, what's happening is that this code is running so fast. It's basically running as fast as it can. There's no time delay in there. And in the moment that I'm clicking the button, like if you go super slow motion, the electronics is like you're pressing 777777777, and then you let go, and it's running so fast that your what you think is a fast click is actually a really slow click. So what we want to do usually in a situation like this, and this happens a lot in embedded software, where you have like a digital signal that gets held by a human being for longer than a computer can read it, you just need to have a debounce. Debounce is a fancy way of saying, hey, just try to remove all the extra fake or ghost presses of that button using some clever trick. And there's a bunch of different ways to debounce, but my favorite is the absolute simplest one, which is just have a time delay. So the first time you see a key press, just time delay by a quarter second so that you don't read any more key presses for a quarter second, and that should ideally be good enough to prevent this kind of issue from happening. And so what you can really do, very simple, is if key.active, you print its name, and then you just sleep for a quarter second. And let's see if that works. Ah, much better. 4, 8, 7, B, 3. Beautiful. So this is very interesting. So now if you actually try to press something twice really fast, it only shows up once, which is also interesting. So you kind of need to like wait a quarter second. And this depends on your application. Everyone likes to do things differently, have different delays. What also you might notice is let's try holding down the button. Let's see what happens there. Aha. So every quarter second you get a 5, 5, 5, 5, 5, 1, 1, 1, 1, 1, 1. So if you want to hold the button, it will allow you to, but it'll only read that number every quarter second. So anyway, our main problem is fixed. Now when we press a button, we just see it once. So that's great. We already have a working keypad. That's awesome. We've gotten so far in just 45 lines of code here, most of which is honestly just setup. That's really cool. That's not completely very interesting. So we have a way to enter the numbers. Don't we want to do something with it? I think what's really cool, or the first time I ever saw keypads was in video games, where I'd have to kind of know the password, in Resident Evil or Metal Gear Solid, and try to get into the door. How would we do that? For me, the very simplest way to do that is to set up a password and then let's say use the pound sign, just like you get on those phone calls. You like put your password and enter the pound sign to enter it. So you use a pound sign as like an enter key, and we'll put in our password. The basic flow is going to be that we're going to scan keys, and then if key.active, we will add it into a list that we're tracking. So we're tracking a list, or a string rather, actually, would be better in this case, which is basically a list of characters. We're going to track the characters that the person entering, and then when they hit pound, we take that whole string and we compare it to the correct password. If it's correct, we say, okay, good. If it's not, then we say no. So I've got a really fun password. It's super long. So let's just start with this. So we're going to say entered password equals empty string. So this is going to track, let's just write that down, track users input, and then correct password equals, and this one's a bit long, so it's a bit hard to remember, but I've copied it over here. Let's say that's the password. Boom. Now you're asking me, why do I have this random, really long number as a password? But if I say it, you might recognize it. It's 01189988119991197253. What we're going to do is every time key.active, we print the key name. But actually, we kind of want it to look like a password. We don't want each character to appear on a new line. It would actually be nice if we were able to print it side by side. So what we're going to do is in Python, we have this really cool, nifty thing in print, which you may not have known about, which is end. What that does is basically instead of printing something and then adding a new line to it, you can add whatever else instead of new line. So in my case, I'm just adding a blank string. So when it prints that character, it'll just print a blank string. And what we actually want to do is we want to handle this pound sign case in particular. So let's just start with that. So our pound sign is kind of like our enter. So if key.name is pound sign, User pressed enter. We're gonna say we're gonna print a new line here because we've been printing characters on the same line so far. And we are gonna say if entered password is the same as the correct password, then we print welcome. Oh, welcome in. Yeah, awesome. Otherwise, we say get out of here. And that's that. Whoops. So this is all in the case where the user has pressed enter. Otherwise, the user has not pressed enter. So we say else. So for any other character, we just print it out to the screen and we add it to our entered password so we can track what they've typed in so far. So entered password plus equals key.name. Oh, and we also want to make sure to clear the entered password in the case where the user press enter so they can start from scratch again. So we're going to say entered password equals blank. So just to go through that really quickly again, the user presses enter, we compare their password so far to the correct password. If it is correct, we say welcome, otherwise we say get out of here, and we reset the entered password back to blank. Otherwise, we just print out the character that they have typed in or that they've clicked on, and we just add it to our entered password, so we just track it. And finally, in any of these cases where if the key is active, we do a debounce right at the end. So I'm just gonna add that comment. Debounce button press. Cool. That's a lot of code. Before we write anything else, let's just give it a shot and see if we're anywhere close to what we're trying to do here. So let's just try some couple of things. So let's just say I put in some random incorrect password. So you see already the password is printing correctly as we want, which is great. And I'm going to hit pound sign. Get out of here. Okay, wrong password. Let's try again. 0118999. Actually, you can just use your keyboard. I just realized. I'm just going to do that. 8819991197253. Pound sign. Welcome in. Awesome. It works. This is great. And I also realize it's much easier to remember the password when I'm singing it than when I'm just trying to say it out loud. Isn't that weird? I feel like there's like a different part of the brain that's involved in singing and music and that it has almost like better memory than the speaking part. So maybe I'll be singing it next time too. Okay, this is cool. So we have a system to enter passwords, but guess what? This has absolutely garbage security. Your password is right there in your code on the website. And if someone wanted to actually build anything secure with this, you couldn't, because if someone could just see your code, for example, it's an open source project, or they opened your laptop pretending to want to watch a movie on it, but then they actually copied your code over, they have access to the password right here. Luckily, we have cryptography and we can do some clever tricks to make sure that we are able to check if someone has put in the correct password without putting the password blatantly right in our code. And that trick is called hashing. So you may have heard of password hashing before. If not, the concept is basically that in computers, you can take any string or data, like a number or a word, and you can hash it, which is put it through an algorithm that spits out a unique, let's say 256-bit set of characters or digits to represent the original input. And it's a one-way function. Like once you hash something, there's no possible way to get it back. You can't go backwards. And that's what makes it secure. In this case, how that can help us is say I were to hash our correct password, and hash the user's input and compare those two hashes. If the hashes are the same, that means the user must have entered the exact same phrase or password as this one, because hashes are unique. And what that does is it ensures that you put into your code kind of this like random long string of characters that nobody understands and nobody can cheat or try to work backwards to get the password from. And that's how you get your security. So that's a lot of theory. Like let's just play with it to see what I mean. So I'm just going to open a normal Python terminal on the side, and we are going to play with this concept. So luckily for us in Python, there's lots of libraries, and there's a library for this as well. It's called hashlib, and it is built in, and it's in MicroPython as well, which is very cool. So from hashlib, we're going to import what is possibly one of the most popular hash functions, which is SHA-256. Sometimes I say SHA-256, SHA. And let's just play with that. So let's apply a hash to a string that we have. So let's say a string is hello. We're going to say SHA-256, hello, and it's probably going to error. Yep. Strings must be encoded before hashing. Okay, so strings need to be encoded. The way hashing algorithms work is that they require an input in bytes format. They just want pure bytes. In Python, that's very easy to do. You just do an encode. So let's say you want to encode hello. There you go. You get like the B means bytes. This is a bytes object. And if I were to do type of that, oops, it's an object of type bytes. And so that's actually what the SHA function is expecting. So we're going to say hello dot encode, and you get this object. Okay, but I want to see the object. I don't want to just try to imagine it. And luckily for us, there's a function for that too. So it's called digest. I don't know what it has to do with digestion, but there we go. Awesome. Okay, so this is our process. We have our input string or data or whatever. We're going to encode it into a byte format, apply the hashing algorithm to it, and then if we do a digest, we get to see the actual output. That is the output. And this is another bytes object because it starts with a B there. And it has in it 32 bytes or 256 bits if you multiply that by 8, which is why it's called SHA-256. So that's all great, but our password is not hello, right? It's that really long password. So I'm going to copy that again. Boom. And I am going to say SHA-256, and we're going to have our beautiful password, encode that into bytes, and digest it. Boom! It looks different. It is different. So yeah, like I was saying before, it always produces a unique output. So like you see that is completely different from that. And what's actually interesting is if you even change one letter or one number, like the slightest thing about it, it creates a totally different output. So say instead of 7, 2, 5, 6, boom, totally different. Has nothing to do with the above output. So this is kind of where the security comes in because no one can just keep trying different stuff until they get closer and closer to the answer. Like it's totally wrong, right? So, okay, anyway, let's go back to the correct one. So that's the correct password and that's its hash. And we actually just want to copy that over into our code. So we're going to say instead of correct password, we're going to say correct hash. And we're going to replace it with this humongous bytes object. Awesome. So now our code is a bit more secure, but we need to actually write the code to compare it correctly. The only thing that changes really is that instead of comparing entered password directly with correct password, you compare entered password's hash with the correct hash, right? So let's change that to hash. And let's use the same code as before, as we did in the terminal, to encode, hash, and digest the user's entered password. So we're going to say SHA-256, entered password, dot encode, dot digest. Yeah, wonderful. So we are now hashing the user's password, comparing it to what the correct hash would be, which does not give away what the actual password is. And if that is the case, then we let them in. Otherwise, we say, get out of here. Okay. And this is awesome. Let's just hit restart over there. And now our new code is running. That's super fast. Okay, so let's try something random there. 1, 4, 5, 7, 8, 9. Enter. Ooh, SHA-256 isn't defined. Yeah, it seems I got ahead of myself there. You got to import the library. So let's do that. From hash lib import SHA-256. And let's try it again. 1, 4, 5, B, A. Get out of here. Okay. Well, that's easy though. Obviously, it's easy to say when the password's wrong. That is usually wrong. But let's try the correct password. So now I have to do it from memory because I can't see it over here. 999 88199 9119725 3. That's it, pound sign. Welcome. Okay, I remembered it. Yes, great. So yeah, there you go. You have a secure way of having keypad entry and password, and it's all in MicroPython with no special libraries required. You basically wrote a keypad scanning algorithm yourself, which is actually really amazing because usually you'd have to use a library for that in Arduino. And that's it. You have debounce as well, which is a really cool concept, and that helps your code kind of not go crazy while still allowing user input. So that's it for today. Thank you so much for watching. I really hope you enjoyed the tutorial. I really hope that this new video format is helpful to see the whole process of thinking about the code. And I really hope you do check out my website. I will be posting this video there as well. If you do want to get notifications whenever I make new tutorials, whether they be video or written, just hit follow down on my website. Or of course, you can just hit subscribe in YouTube as well. Thanks for watching. Till next time. Bye-bye.